Hello, am I audible? We will begin our session in 1 minute. I hope I'm audible to everyone. Hello. So, good evening, everyone. Thank you for joining this webinar. So, I think it's time we start our webinar for today. And I hope my voice is loud and clear. Okay, so let's begin for today. We have provided you data sets and materials required for this webinar. I'll try to be as slow as possible. If you want, you may practice with me. Otherwise, this webinar will be available on the YouTube and you can go back to it later and work at your own pace as well. So, greetings everyone. Welcome to QGIS Master Class. This is our third webinar in the series where we take webinars mostly we try to take webinars every month, and this remains free for everyone to join, but whoever registers for it will only get the certificate. That is the only thing. Otherwise, you may share the link with your friends. Anyone can join. That is why we keep these webinars on YouTube. So in this webinar, we will discuss the integration of remote sensing and GIS, very powerful technologies of today's time. And for today, we will learn the application for coastal environment application using QGIS. So we are going to use the QGIS software for our analysis. And I hope you all are excited to dive into learning the new skill by the end of this webinar, and you will be encouraged to learn this open source software. Okay, so about myself, I'm Dr. Neha Joshi. I will be your trainer for this current webinar, and I have 8+ years of experience in working with GIS softwares like QGIS and ArcGIS. I hold a PhD degree in geology from Kumaon University, Nainital, Uttarakhand, India. So I completed my PhD in 2020, and subsequently I did my postdoctorate from Friedrich Schiller University, Germany. And in 2023, along with one of my team members, we founded Quest GIS, in which we regularly take courses on QGIS and its fundamentals and applications, and many more. So, why we chose, just a minute. So why we chose QGIS? Because we strongly believe that it's a very powerful software, and again, open source, accessible to all, and no less than its licensed counter softwares, in which you have to pay heavy fees for performing almost similar operations. Okay, so once again, I want to say that those who have registered for this webinar, my team has provided the data sets, study material again and again through the WhatsApp group or through email. So I hope you all have received that. Otherwise, if you have, see, even if you have not registered for this course, you may go to the description box of this YouTube live and download the data sets. Okay. And I hope you will be able to download them without any problem. And so let me again brief this webinar. So in today's webinar, we will first build the basics of remote sensing and its application in coastal environment management. We will then discover the several issues in coastal regions of India. And of course, these are the issues prevailing worldwide, and how GIS and remote sensing can be integrated or combined to find the solution, to map these issues on space and time. And for hands-on, we will focus on one of the application, which is mangrove forest cover mapping, because they are quite important in coastal environment, coastal diversity. Okay, so before we dive into the theoretical and the practical part of this webinar, I want to announce that for our registered participants, and special announcement for everyone will be in the end. And in the end, I will share the details on how to download your certificate of participation, okay, and how you will be benefited in our upcoming courses. So stay tuned till the end. And so without any further ado, let's begin our uh, course. Let's begin our webinar. Okay. So, so basically, let's begin with the basic question, like what exactly is remote sensing? So remote sensing, as we all know, it's a science that involves the data capture using special cameras embedded or built on the satellites to collect the data from distance, right? So these satellites are rotating or revolving around our earth, and they capture data on certain space and certain time. And these data, which is remotely collected, provides valuable information about the earth surface and atmosphere. Okay, so there are basically several steps involved in in remote sensing, in collecting this data and analyzing this data. First, you require a energy source or illumination source. So basically, energy sources are the natural sources, or for example, your sun, which can emit light, emit electromagnetic radiation. And these electromagnetic radiation can also be emitted by artificial sources like radar, right? And these electromagnetic radiation uh, then interacts with the earth surface or interacts with the atmosphere. So when it interacts with the atmosphere, with the atmosphere, there are some wavelengths of this electromagnetic radiation which is scattered, and some are absorbed, right? Some are absorbed by the particles or the gases in the atmosphere, affecting the amount and the direction of energy, right, that reaches the earth's surface. Not all the energy emitted by the sun reaches the earth, right? It is being scattered, it is being absorbed on its way. Then once this some portion of this electromagnetic radiation reaches the earth surface, it then interacts with the earth surface features. And we all know that there are different type of earth features on the earth that are made up of different materials. For example, water, vegetation, soil, they all reflect, right? Some of them reflect, and some of the electromagnetic radiation is being absorbed, right? And that is done very differently for every different earth surface feature. So this reflection and absorption or emission is captured by the sensors installed on the satellite, right? And they are recorded by these sensors. So there are basically two types of sensors. So first is your passive sensor. These sensors are detect these natural energy that is reflected or emitted from the earth surface. Example, your optical and thermal sensors. So these sensors are installed, or you can say fixed, on the satellites that receive those emissions, reflected emissions from the earth surface features. And active sensors, they emit their own energy and measure the reflection from the earth surface. For example, your lidar and radar. Okay, so they themselves emit the energy, and the reflected energy they sense and transmit, right? Transmit to so further transmit for further processing. So this data which has been sensed is actively or passively sensed and captured, and is then transmitted to ground stations, okay, via satellite communication. So ground stations receive the data on and store it for further processing. So the raw data is processed to correct any distortion. Of course, our earth surface, the angle between the satellite and our earth surface feature is not always vertical, that it will capture the true heights or the true shapes. So there is always distortion. So these distortions need to be corrected and converted into usable formats, for example our images and maps. And we get these images because we are the analyst, we are the users of these images. So for us to use these images, for us to analyze these images need to be free of any sort of distortion. So for interpretation by the analyst of these images and maps, the analyst, what they does, they visually analyze the processed images to identify features and patterns, right? So with digital analysis, advanced software is used to analyze the data quantitatively, extracting specific information like vegetation indices that we will learn today, and land cover types. Again, we will learn these two things in our webinar in during our hands-on practice. And temperature variation, you can perform so many things with these satellite data, and monitor and map the changes with time and with space. Okay, so these are the steps involved while when before you get the satellite image on your desk. Okay, so then comes the resolution. Our satellite images have different they have different level of resolution. Different level of resolution means different level of detail that a remote sensing satellite can capture. So basically four types of resolution is there in the satellite image. First is our spatial resolution. So for spatial resolution is defined by the size of the smallest object that can be detected by the sensor. Okay, for example, a satellite image, if we say that we have a satellite image of spatial resolution 10 meters, that means that that image is capable of, or we will be capable of distinguishing objects that are at least 10 meters apart from each other. Okay, below that or less than that resolution, we won't be able to resolve in that image. Okay, so smaller the spatial resolution, better are the images. Okay. Okay, next is our spectral resolution. Spectral resolution is the ability of the sensor to distinguish between different wavelengths of light. For example, if we talk about the multispectral sensors, they capture data in specific wavelength bands. Okay, while our hyperspectral data that capture data in hundreds of narrow bands. Okay, hundreds of narrow wavelengths it can capture. Okay, so this is how our spectral resolution provides us the satellite data in different bands. So temporal resolution, so as the name suggests, it is related to the time. Okay, so the frequency with which a sensor can capture data of the same area. Okay, so for example, if a satellite has a revisit time of, let's say, 3 days. Okay, that means that the satellite with a temporal resolution of 3 days can revisit and capture data of the same location every 3 days. In this case, you by taking the advantage of the temporal resolution, you can find out the post seismic events, the landscape of pre-seismic and post-seismic events, and you can utilize such information in landslide events, like the what was the land how was the landscape before the landslide, and how much of the how much of the land is got there was a rock slide, how much of the land was driven by that landslide. Okay, so temporal resolutions are important when you want to do some temporal analysis or time based analysis. Then comes our radiometric resolution. So radiometric resolution defines the sensitivity of a sensor to detect slight differences in energy, okay, or the brightness. For example, 8 bit radiometric resolution, if you have a 8-bit radiometric resolution image, then it can detect 256 different levels of brightness, that is shown in different levels of grays. Okay, so this is one of the concept very important in remote sensing, and I hope this was clear with all of you. Then comes the bands. Okay, so we said that our spectral resolution is able to distinguish between different wavelengths of light. Okay, so what does different wavelengths and different bands mean? So band refers to the specific ranges of wavelength. Okay, specific ranges of wavelength that our sensor can detect. For example, if we have the visible band, okay, if there is a satellite that can only operate in visible band, so what does that mean? That means that the that satellite will only identify the wavelength range between 0.4 to 0.7 micrometers that a human can visualize. Okay, for example, it has applications in natural color images, vegetation analysis. There is near infrared, there is short wave infrared bands, there are thermal infrared bands, and there are microwave bands. Okay, so if we talk about the microwave bands, that means that that wavelength range is between 1 millimeters to 1 meters. So we will see what are these different bands in our exercise as well. Okay, so I'm not going into the details here. We will see how do they look like, but you have to understand that these satellite images are gathered in different wavelength bands. Okay, that which you will combine to see the different earth surface, different real earth surface features using a GIS software. Okay, then comes the application of remote sensing. Okay, so basically you can identify the forest fires, you can identify the landslide events, you can identify the changes, deforestation, urban expansion, everything using the remotely sensed images, uh, which is again gives us different signals based on the time of the year in which it is captured. Okay, so if you are interested in let's say understanding how the cyclone is moving, okay, so you have to check the images of that particular time. If you want to see the how the earth moved during the landslide or during the earthquake, so you have to identify, you have to check whether the temporal resolution of a particular image allows us to look into that particular time interval or not. So based on what exactly you want to see on those images, what changes you want to identify from those images, you have to select what image or what satellite data is required for you. Okay, so this was all about the basics of remote sensing. Now let's get into to understand why should we study the coastal setting, as this webinar is dedicated to understand the the application in the coastal environment. So why exactly that is required? Because coastal settings, if you look into it, they are kind of provide barrier between the land in which we live and the sea in which there is a different, entirely different settings, right? These coastal settings in which diverse ecosystems thrive, and they are known to be highly productive regions like mangroves, coral reefs, lagoonal, estuarine settings. They kind of form a transition between the land and the sea, and they need to be protected because if they are not present, let's say mangroves are not present along the coast, then all the cyclones will hit the land very badly, because they form like a natural barriers to these winds coming from the sea, right, and protect a lot of human life, you can say. And they have, again, of course, not only beneficial for human life, they helps us in regulating the nutrients, filter pollutants, and help to protect shorelines from erosion and storms, right? And they also have high potential for marine fisheries and oil, gas, and mineral resources. So we need to study these coastal settings, what are the changes occurring in time and space. So basically, what are the major issues related to these coastal settings? So issues that need to be addressed in the context of coastal zone management and its protection are coastal ecosystem and marine living resources. Okay, coastal development for urbanization, this is the main threat, this is one of the main threats in the coastal environment. Degradation, coastal water quality due to the industries set up, or industries or the ports set up along the coastal zones. Coastal water quality is very important to is of lot of concern. Shoreline protection, coastal hazards, and climate change. So all these are one of some of the major issues that we have to address, that we must address when we are studying the coastal settings. Okay, so these are some of the negative impacts on coastal environment. As we have already discussed, there is habitat degradation. Okay, there is pollution, like for example, recipient of all waterborne waste streams, primarily attributable to agriculture, its fertilizers and agrochemical, and all treated and untreated municipal and industrial waste, they all drain into the coastal waters. Okay, population pressure, you can see that the coastal regions are being deforested in order to establish the urban zones, right, in order to expand the urbanization, there is industrialization and everything, and due to which there is over exploitation of marine resources. Okay, and conversion of wetlands, which is highly productive system in offshore activities, as we have also seen in the case of Chennai. So Chennai floods, right, of I think 2015, there was floods in the Chennai due to, and it was identified that all the wetlands have shrunk due to the urbanization. Okay, so and because now water do not have any, water is not getting absorbed, so it is always, the city is always flooded during the monsoon, and there are multiple resource use conflicts in the coastal environment, which causes the negative impact on coastal environment. Okay, so now what, these were the problems, so what is the solution, what exactly we can do, what, why we have gathered here for this webinar, so that we have the idea like what exactly we can do. By learning just one of the applications, we can understand the expansion of this particular technology, which is GIS and remote sensing. Okay, because if you have noticed that most of this information and data is likely to have spatial component. Okay, so with space the images are being captured, and for example the, so one branch of information technology, so significantly contributing significantly to coastal management in number of ways is GIS. Okay, so GIS can contribute a lot to this specially distributed images, and of course there is time domain as well. Okay, so these images are being captured at different time, so of course we have the time domain which we can analyze using the GIS. Okay, so remote sensing techniques generate spatial data, of course also temporal data, which are analyzed in GIS environment for spatial and temporal analysis. Okay, so you can take the Landsat images from let's say 1998 of the same area, and then you can take the Landsat images, let's say from 2024 for the same area, and you can check what is the change in the land use cover in these many years. Okay, in these 20 to 30 years, what was the land cover changes as that has happened, and is there any deforestation or afforestation, what is the extent of urbanization, okay, where the wetlands are there. Okay, is there any pre-existing wetlands which is now they are degraded or not present at all, and what was the changes in the shoreline. So we have all these dedicated lectures in our YouTube channel as well. If you are interested, you can go and check those videos about shoreline change analysis as well. So basically our GIS assist in integration of various data. Okay, this is the basic use of GIS. It helps us in integrating various data, whether it is a remote sensing data, whether it is your field collected data, okay, anything, any data it can integrate, and it can help you in applying the modeling techniques to derive a better picture of the study area and framing new policies and development of management plan. Okay, and remote sensing in combination with GIS is a powerful tool for management of coastal zone ecosystem sustainably. So if you integrate the various data from different time zones and found out that due to the deforestation or urban extension the city is always flooded, then you may you may declare a policy, you may advise the policymakers to implement more action towards the afforestation of developing wetlands in the area, or restoring the wetlands that were pre-existing, right? So these type of things you can integrate by combining the remote sensing and GIS. Okay, so now we have talked about the technological action. So let's begin our working in the QGIS now. Okay, so I have given you the data sets. Okay, and we also provided you that how on the video tutorials on how to install QGIS, what are the ways of loading data into QGIS. So everything was provided beforehand. So those who registered like 1 week before, we provided them the all these details 1 week before only. So I hope they at least they are ready with their QGIS installation and everything. And if you haven't done that yet, please go through the videos in the YouTube channel, and in the by the end I'll provide you all the links from where you can download all these things, and come at the stage. Okay, now, so this is my QGIS interface. If you look into the interface, it's very simple, very straightforward. Okay, so here you have the menu bar. This is your menu bar in which you have the menu of all the items, all the processing that you can perform in QGIS. You just have to click and expand the options here and you will find everything. So we have a dedicated lecture for QGIS interface. It is just a 15 minutes video. If you are interested, you can go and check that as well. So this is all the menu options available in the QGIS. Okay, and this is your layers panel, this is your browser panel, okay, where you can browse things from your computer, from the internet, from anywhere. If you have stored anything, then you can browse all the information from here. And this is your project toolbar. Whatever tools you are using frequently, that is provided, that get settled into this uh, project toolbar. Okay, so it consists of different toolbars. For example, if I move my mouse here, so I will see this as a selection toolbar. If I move my mouse here, I will see this is the annotations toolbar. So how do I get all these toolbars here? So it is just a simple right click on this gray area of menu bar, and here you have the list of toolbars and panels that you might be interested in. Okay, next is our side panel. So in side panel, you can set any of these toolbars, just drag and drop it here. Okay, like this, just drag, use the left click of your mouse, hold that and drag it to the desired place. Okay, that's what you can do to get into the side panel. Okay, this is your workspace. Okay, whatever project you will be working, is it will be loaded, it will be loaded here. Okay, so yeah, so I hope this is till this point everything is clear, everything is easy to understand. Okay, now comes our first thing that we have to install. Okay, we will learn how to install any plugin in QGIS. Okay, so you can see there is one option which is called plugins in your menu bar. Okay, so you have to click here and click on manage and install plugins. Okay, so you need to have a very good internet connection to get this list. Okay, so here you will see there are different options. There is all this is these are all the plugins that is available with QGIS. For example, for me it is 1454. You might have different number here. Okay, and among 1454, I have installed only 21 plugins which are of my use. Okay, so the plugin that we have to install is semi automatic classification plugin. Okay, but you will find semi automatic classification plugin here as well, but I have provided you a zip file which is a little bit older version we are going to use here. Okay, so for that, if you have any zip file for a plugin in Q and you want to install that plugin in QGIS, of course it should be compatible with the QGIS. So for that, what you have to do, you have to go to install from zip, click on these three dots. Okay, and it will take you to the folder. Okay, and in data folder you will find the semi automatic classification plugin. Click on this, click on open, and then click on install plugin. Okay, so once it is successfully installed, because I have already installed, I don't want to overwrite it. So once it is successfully installed, you can close it. Okay, and after that you will get this SCP option in your menu bar. Okay, here you will find it, SCP option, one option is there, and right click on the menu bar and select all the things related to SCP you find in your panels and toolbars. For example, SCP edit toolbar, SCP working toolbar, right? And there is SCP doc panel. So you will find all this thing in your panels and toolbars. So you have to get all of them activated. Okay, so I hope this was clear. Am I too fast? Is there anyone can tell me if I'm too fast? Okay, I'll get back to QGIS now. Yeah, So after we have installed our plugin, we will go to SCP. Okay, and we will go to band set, because our satellite images are prepared in different bands, different wavelength bands. We will click on band set. Okay, and using this open a file icon here, we will click on it. It will take us to the folder in which we can load our images. Okay, so these images are in TIFF format. So you have to select all these files together by pressing the control button on your keyboard. Okay, press the control button like this and open all of them together. Click on open. Okay, and if you haven't if you get this band set 1 here, then fine. If you are not able to get this band set 1 in the band set definition, then select all of them by clicking this button and then click on this plus button here. Okay, and after that you have to perform wavelength quick settings, okay, which is our Landsat 8 here. Okay, because this is our Landsat 9, but for Landsat 8 and Landsat 9 there are the settings are similar. Okay, so don't close it, just minimize it. You see, all our images are loaded. So where you can, so the question is now that where you can see all these images loaded, all these different bands are loaded. Okay, that you can find in your layers panel. In the layers panel you will find it. And how to get this layers panel, as I already said, you have to right click and activate this layers panel here. Okay, so now I'll switch off my camera, because if I switch on keep it on, then some of the things that I will be doing in this space of my QGIS interface, it will be hidden from all of you. So I don't want to do that. So I'll close my camera for some time now. Okay, now I think the entire screen is visible to all of you. Okay, so these are different bands. If I expand it here, you can see the B7, B6, B5, B4, B3, B2, B1. So what is this B1, B2, B3, B4, B5, B6, B7? I'll provide you this document here. So for Landsat 8 and Landsat 9, all these bands, like for example Landsat 7 is your short wave infrared, band 5 is our near infrared, and these are the wavelength ranges that this particular band captures in Landsat 8 images. Okay, and all these images are gray in color. Okay, so why they are gray in color? Because they are just representing the intensity of reflectance. Okay, they are not representing the color, they are just representing the intensity of reflectance of reflectance from the earth surface features. Okay, so that is why they have different shades of grays. If you will activate and deactivate them, then you will be able to see that. Okay, okay, so I hope this is clear. This is how we can load the satellite images in QGIS. Okay, but this is not a traditional way of loading data in QGIS. If you want to learn how to load data in QGIS, I will refer a dedicated video, okay, for vector data, for raster data, and for delimited text data. So we have dedicated videos in our YouTube channel. You can go through it. It's very easy and very easy to understand. And if you have any doubt, and if you're there in the WhatsApp group, you can ask me your queries. Okay, next is, let's go back to our theoretical part. So this is where we have loaded our data. This is where, as we said, GIS helps us in integrating various data. So we have tried first loading the data. Okay, now, so as we said that there's a GIS technology and coastal management. Okay, so these are uh, 12 to 13 problems or issues in the coastal zone management of Indian coast. Okay, for example, if you will see this green part, this green thing, this is the population pressure on along these coast. For example, this is 2 Okay, this is 2, 5, 6, and 11. They represent the problem of mangroves and coral reef ecosystems. Okay, so in this way there are a lot of problems, lot of issues, natural and as well as man-made issues that are occurring in the along the Indian coast. Okay, and of course this is not just the problem of Indian coast. These are the problems that must be prevailing in other parts of the world. Okay, but among them we are just going to focus on mangrove mapping using Landsat satellite data. Due to time constraint, we will just take the 2025 image. Okay, but in the same way you can take the images of different time and analyze the changes. Okay, analyze the changes in the in the mangrove forest cover, okay, or urbanization or the other land use, other land covers. Okay. Now for our mangrove sorry, for our mangrove case study, we will focus on the along the Kakinada Bay. Okay, so it is in Andhra Pradesh. It has been impacted by the deforestation of large scale deforestation of mangroves in this region. So we will consider this particular area for our analysis. Okay, and you see there is a lot of aquaculture happening in this area for fisheries, of course. Okay, and because of which there is a lot of deforestation and urbanization, uh, factory settlements and everything is there. So because of which there was mangrove degradation due to aquaculture along Kakinada coast. Okay, so basically why mangroves matter, why we are focusing on that. So if you will go into the entire slide, you will understand that mangroves are they not only protect the salt water, but they also protect the freshwater ecosystem, which is on the landward side of mangroves. Okay, so these trees they actually stabilize the shorelines, preventing erosion and protecting the land. But otherwise, if these forests are not there, then these lands, will be eroded with time, and there will be so much of seaward ingress, right? There will be landward ingress of seawater. Okay, and there will be destructions from waves and storms every time. So these trees basically trap sediments and pollutants that would otherwise flow out to the sea. Seagrass beds provide a further barrier to silt and mud that could smother the reefs. Okay, so basically these trees also provide us fuel, medicines, tannins, and wood for building houses and boats. Okay, so from every aspect, protecting mangroves is quite a important thing. Okay, so this is going to be our methodology for current webinar. So we have collected the data. Okay, we have got our Landsat data, Landsat 9 data. And this data is already pre-processed, geometrically corrected. Okay, once when you will download it from the USGS website, it is already geometrically corrected. Now we are using this geometrically corrected data for unsupervised and supervised classification. But in this webinar, we will focus only on the supervised classification. Okay, and then after the supervised classification, we will see the mangrove forest cover in this area. And then after that, we will calculate the vegetation indexes useful in mapping out the mangrove forest cover or any green forest cover in the area. Okay, next is why do we even do these image classification. Okay, so what is image classification and why do we even need it? Because image classification into based on the spectral signatures of the earth surface features is important because it makes sense of the landscape and place landscape into the categories, for example forest, agriculture, water, soil, etc. Okay, and the classification scheme, it again depends upon the needs of the user. So how it is done, we use the radiometric properties of remote sensor, different objects, as we all know, different objects have different spectral signatures. So in the easy word, if we talk that all vegetation pixels would have exactly the same spectral signature, right? But in reality, this isn't the case. So if you look at the several pixels with vegetation, again, we will see in our work during our hands-on practice. So you will see a variety of spectral signatures coming out from the vegetation. So the same would happen for other types of pixels as well. Okay. So all the built up areas won't have the similar sort of pixels. Okay. You can reclassify them by making the different band combinations. Okay. So basically, as I said, there are two types of image classification: unsupervised, in which we just use a computer-based automated classification. We just tell our computer system that this is the algorithm that you want to use to provide us these many classes. Okay, we provide some thresholds using which our computer perform unsupervised classification and give us the final image. It generates clusters and it assigns those clusters based on the spectral signature. It generates the clusters and then it assigns the classes. Okay, then comes our supervised classification. So supervised classification is done by the user or image analyst who supervises the pixel classification process. The user specifies the various pixel values or spectral signatures that should be associated with each class. Okay, we will learn this supervised classification in our exercise. This is done by selecting representative sample sites of a known cover type called training sites or areas. We will prepare these training sites for our supervised classification. So steps involved: first we collect the training data, there is feature extraction, classifier training, and then pixel classification is there. Okay, so these are the algorithms that are used in supervised classification. We are going to use the minimum distance to mean. It uses the mean vectors for each class and calculates the Euclidean distance from each unknown pixel to the mean vector of each class. The pixels are classified to the nearest class. Okay, so we are not going to use the maximum likelihood here. Okay, now again, let's go to QGIS and learn how to perform the supervised classification. Okay, so as I said, we don't have to close this, we just have to minimize it. Okay, then we will go to band processing. In band processing, we have to select classification. Okay, so just keep this window like this and minimize it. Okay, now as I said, these are the different bands which are showing the different intensity of reflectance. Okay, so now we will combine these different bands, different spectral bands. So there are two types of composites that we can create. First is our true color composite bands. Okay, so if you combine 4 3 2 bands, 4 3 and 2 bands of this 4 3 and 2 band of this Landsat image, then you will get the true color composite. Okay, so you will find the red, green and blue composite. What are okay, let's again see what is 4 3 and 2. So 4 is our red, green and blue. Okay, so these are the primary colors. So when we combine these primary colors, we get the true color images of the earth surface features. Okay, so vegetation appears to have darker green color than other vegetation. In a true composite, vegetation appears green, but it doesn't differentiate between healthy and stressed vegetation as effectively. Okay, so you will see the difference one by one. So let's first create 4 3 and 2. So how we are going to create this? So in this RGB you will find this blank space here where you have to put the numbers. Okay, so 4 hyphen 3 hyphen 2. Okay, then enter, press enter key. Then a virtual band set will be created. Okay, so right click on it and move it to the top. Okay, you see, this is our true color images and looks something like a Google Earth image. Okay, so if you want to see the Google Earth image of this area, then you have to go to web, okay, and go to quick map services. Of course, you do not have this quick map services plugin if you are using QGIS for the first time. Again, we have a dedicated video on how to install and use this quick map services plugin, so please go through that video. Okay, and Google, and then Google satellite. You can load all these Google satellite image in just a second. Okay, Google satellite image. Okay, so this is our Google satellite image for the area. I will bring it to the uh, bring it here. Okay, and so that we can compare. Okay, so this is basically our true color image of this particular area. Next type of composite that we can create is false color combination. Okay, false color means other than if you are mixing anything with let's say these primary colors, for example 543, you are adding near infrared to red and green, so that becomes our false color composite. Okay, so infrared red green displays vegetation as darker red compared to other vegetation. Healthy vegetation in this 543 reflects a lot of near infrared light, which is captured by band 5. Okay, when displayed as red, areas with dense healthy vegetation appear bright red, making them stand out clearly. Okay, so let's see if this happens in this area or not. Okay, so the combination that we are going to put here will be 5s hyphen 4 hyphen 3. Okay, so you see this has become our false composite image. I'll zoom it. Okay, so the darker red areas is our healthy vegetation. Okay, and this pinkish red, which is quite different from this red, is all your agricultural land. And but within this pinkish shade you will find these dark red. Maybe these are some other type of plantation that is present in this area. Okay, but here you see this is brownish reddish color. This again shows the healthy vegetation in this area. Okay, so this is how you can interpret this image. And you see the water body here, the water is dark in color because it is clean water. Clean water is darker. Okay, and where the water is laden with sediments, it is slightly bluish in color. Okay, you will find the difference here in this satellite image. Okay, so next composite that we can try is 5, 6 and 7. Okay, so okay, let's talk about 5, 4, 3 a little bit more. So this makes it easier to distinguish between forest, grassland and agricultural field. Okay, cities here are appears as gray or tan. Okay, so let's go back here and see. These are the cities. Okay, so this is your cyan tan color in this particular area. However, this color is, you see this color here, and this particular spectral signature or this particular spectral signature looks same, right? We are not able to differentiate these two cities and the sand or the bare soil in this particular combination. So another combination comes into play, which is 5, 6 and 7. So here we have infrared, mid infrared and mid infrared 2. Okay, or infrared, okay, short wave infrared and short wave infrared 2. So now we are going to combine these three and we will see what exactly we get the results. Okay, so I'll go with 5, 6 and 7. Okay, you see the image has orangish tint, orangish color. Okay, different shades of oranges for vegetation, and for the urban sector, urbanized area, we can see a different color here. Okay, we are able to distinguish between the bare land, the land which is used maybe the crops are no more there, the land is bare. Okay, and we can see the difference between the cities and the bare land, which we were not able to find out or identify the difference in our previous combination, which was 5 4 and 3. Okay, so I think these combination 5 6 and 7 is the most useful in identifying the vegetation and other land cover types. Okay, land cover and land use types. Okay, so the approach that we are going to use here, it is similar to the approach that you can utilize in while preparing your land use land cover maps using QGIS. Okay, so this is what exactly you can do with the paid versions of other softwares, and this is what you can do for free, and you can access all these images for free and perform these analysis for free. So I hope you are encouraged to use these open source and freely available resources. Okay, so yeah, so let's go into its analysis. Now we will go to scp doc. Okay, in scp doc, now we have to create our training inputs. Now we have to train our model based on the satellite data, satellite signatures, satellite spectral signatures that we have here. Now we have to create our training inputs. Okay, so we will give inputs, we will train our model that this particular spectral signature is for urbanization or built up areas, and this particular signature is for, let's say, mangroves. Okay, and this particular signature is for farmlands or bare soil. This particular signature is for, let's say, some other plantation. Okay, etc etc. We are going to prepare different classes. We will classify this image in different classes now. Okay, based on the spectral signatures. For that, we need to create training input. Okay, so let's create training input, create a new training input here. Okay, so make it a folder, give it a name, training input. We will keep everything very simple. Okay, there are so many advanced things that you can do here, but I'll try to keep everything very simple. Save. Okay, so we have created our input layer. So where you can find it in the layers panel, TIs. Okay, go to scp doc again. Now you see there is MCID and there is CID. So MCID is your macro class ID. Okay, so for example, if you create a class for vegetation, so there will be different type of vegetation in this area, so that will be classified as different classes. Okay, and one macro ID will be, let's say, green cover or vegetation. Okay, whatever name you want to give. So we will just focus on the macro IDs here. We are not going to reclassify the vegetation. We will just pick up, the green covers here. That's it. Okay. So our first macro ID will be, let's say, vegetation. Okay, I'll start with the water body. Okay, water bodies. So let's keep it class 1 as class 1. Okay, if you want, you can use different band combinations to differentiate between your landward water bodies, or differentiate between the ocean. Okay, but we will just differentiate them as water bodies because this is not our objective. Our objective is to pick up only the mangrove pixels. Okay, and after that you have to click on this create a ROI polygon. Okay, so just create a ROI polygon, click on this and go to water bodies. Okay, so if you will see here, if I'll scroll down here, then for our water bodies, okay, so this values are negative values. So what are these values? Actually, these values that you see here are our NDVI values. Okay, normalized difference vegetation index. These are the NDVI values that you can see. If I put my cursor over the water body, you can see these are the negative values. So based on these NDVI values, you can also identify these water bodies. Okay, so I'll just start marking my training inputs. Okay, so for that, uh, start working as if you are digitizing this area. Okay, so just make a polygon. Use the left click of your mouse. Okay, right click of a mouse and create a some polygon which can cover some area. Okay, and right click to finish it. Okay, next go to another place. Let's go here and pick up the pixels again. Okay, so but you see we have already created one polygon. So in order to collect more samples for this particular class, we have to press the control button on our keyboard and then start collecting your sample points, training points. Okay, right click to finish it. Let's collect some more samples from here. Okay, try to collect the samples uh, or try to distribute the samples specially. Okay, collect samples for the same object, same feature from different parts of the images. Finish it to right click to finish it. Okay, I'll another take one more sample from here. Okay. Then let's collect some more sample. Take at least 10 samples. Okay, this is the minimum, but more samples you take, better your classification will be. Okay, I'll take some samples from here as well. Okay, these are all our water bodies. Let's go to this part and collect samples from here. So it is giving us slightly positive values because it is, surrounded by mangroves. So there will be some of the greener part present in the water bodies as well. Maybe some algae or some shrubs. Okay, so that is why it is giving us these positive values as well. Okay, so let's collect some samples from here. So I think, okay, let's do collect some more samples from here as well. Okay, yeah. So once you are satisfied with the number of sample collections, number of training inputs collections, then you have to save this file. Okay, save these signatures. So by clicking on this button here, red or yellowish button here, so click on it. It will create ROI. It will calculate signatures. Okay, it will take few seconds. So what exactly is happening here? We have given few inputs to our model to understand the spectral signature of water bodies. Okay, so that by understanding these pixels distribution, it can distribute or it can understand the distribution of water body in the entire image. Okay, this is what we are doing. We will change the color later in the last, but for now let's create one more class. Okay, so second class I'm going to create for my built up areas. Built up. Okay, built up zones. So please remember to change the macro class ID. Okay, and under second macro class there will be, so this is going to be our first class ID. Okay, so let's go to our urbanized area. And if you are not sure whether this area represents urbanization or built up areas, then you may go to layers panel and switch this off to check in the base image as well. Okay, this will also help you. The base images also helps us in identifying these areas. Okay, so this is, so now you can understand that this particular color or this particular signature is for built up areas. Okay, now again let's go to this ROI polygon and start selecting the sample. Okay, select the first sample without pressing the control button for each class. But once you have selected the first input, then if you're going to another place, so you have to press the control button Okay, control button, and then start collecting the sample and right click to finish it. Okay, so I'm zooming in and zooming out using the mouse scroll bar. Okay, so you may use the mouse scroll bar inward or towards your screen to zoom in. Okay, and towards yourself to zoom out. So now I'm identifying different portions of this image to find out the pixels that represent the urbanized area. Okay, for example, this area. You may avoid taking this particular cyan color here, okay, because this represents some bare land, maybe some exposed land which is not constructed, or which is that represents some bare soil. Okay, so just take samples from this particular bluish color here. Try to take as many samples as you can. Okay, like this. Keep pressing the control button when you're moving to another portion to collect the same sample for the same class. Okay, like this. You may take any shape. Okay, don't worry about the shape of these polygons, because anyway these are polygons, it can have any shape, but they should be enclosed. Okay, they should enclose some area. And yeah, we have taken one sample from here, so I think we have collected many samples from here. Let's go to this part of the image to collect the sample. Okay, and again, so I, because this built up areas are, you know, clustered in different parts of this image, so I would like to take samples from different parts of this image so that my model is trained well, and when it finalizes the pixels, it is not confused. Okay, so you may identify some more pockets, for example here. Okay, here as well. Okay, and yeah, we have taken samples from this portion. Let's take some samples from here as well. You can be very accurate. Okay, I'm not doing it with a greater accuracy, but you can be very good by zooming in and just identifying the pixels that you think represent the built up area, like this. Okay, maybe in my analysis right now I'm covering the spectral signatures from other features as well. Okay, so of course this webinar is for the demonstration purpose. Okay, I think we are done with the with collecting the samples for urbanized areas, urbanized pockets. Okay, so once you are done and if you are fine with the sample collection, you may go to SCP doc and save the signature. Again, it will take few seconds. I hope this is clear with all of you why we are collecting such samples and what exactly this model is going to work, how it's going to work. Okay, so let's avoid this warning here. Okay, so we have created two classes. First is for water bodies, second is for built up zones. Okay, now I'm going to collect one more here, which will be my agricultural land. Okay, agricultural land. Okay, again, when you have created another macro ID, class ID will be 1. So collect the sample. So start collecting the sample for your farmlands or your agricultural lands. Okay, so you see it is showing us a very high NDVI value, because at the time the picture was captured, maybe the vegetation was quite healthy. Okay, see these high NDVI value shows healthy vegetation. Okay. We will collect samples from here as well. Now again, we have to specially distribute our sample taking process. Okay, like this. These are all our agricultural lands. If you want to confirm whether it is yes or whether it is your agricultural land or not, you may go to the base image and check. Okay, you see these are all our cultivated lands, and there is a lot of healthy vegetation you can see from your even from your base image. Okay. Again, activate this. And let's see how well our model can differentiate between the mangrove signature and our farmland signature. Okay, you can just take roughly a bigger polygon because this is all your farmlands, like this. Okay, one more here, and let's take one more here, and on this side as well you can see a lot of farmlands. So just take a bigger sample from here, sample from here. You can refine these samples later as well. Okay, if you think that your results are not correct, you can refine them later, and let's see if we get the opportunity to work on that as well. Okay, so let's take these pixels as well. Let's collect some sample from here. Okay, so if you wherever you want, you can take these samples. Okay, I think we are enough. We have taken enough samples from every portion of this picture, and we'll go to SCP doc and save it. Okay, it will take again some time to calculate the signature. So if you have any questions, please write that in the chat box. We will take the questions in the end. Okay, so these are all our samples that we are collecting. Okay, these are all the training inputs that we are collecting from using the spectral signatures present in this image. Okay, and how we are doing that? Again, we are just you know, ticking the boxes, ticking using the left mouse click, or we are just creating some area, our region of interest we are creating, that we are telling this our model to, we are telling our model to you know, collect, understand the spectral signature and create a model, or understand the spectral signature, create a final image out of it. Okay, so if you are not able to understand at this point, please wait and until you get the last ultimate result. Okay, now another thing that I want to add here is one more class we are going to add. Okay, that will be our bare soil, bare soil, or let's say sand. Okay, because sands are present in our coastal regions, so that will be macro id will be 4. Okay, and class id will be 1. Okay, so this is the sign of our sand present in this area, and if you want to check whether it is, so you may switch this off and check it. You see, this is all our bare land as well. That is why it is showing us the similar spectral signature. Okay. Okay, now let's collect our samples for bare soil or sand. Okay, use the left click of your mouse to start digitizing or start tracing or start collecting the sample. And for more than one sample, you have to collect, you have to click the control, you have to press the control button on your keyboard. Okay, start collect the samples from multiple places. Distribute it in, distribute it spatially. For example, if I switch this off here, I can see that there is a bare land here again. Okay, so I'll collect one more sample from here by pressing the control button. Okay, like this. One more sample from the coastal line as well, shoreline as well. Okay, from here as well, you can take one more sample. From here, and let's take one more sample from this portion of the image as well. It will map all the exposed land with the land which is not covered with the green vegetation or anything. Okay, any built up or any other cover. So it will just take the bare land for this sample, for this training sample. Okay, so I think we have collected enough sample for our bare land, and then we will save our signature. Okay, it is taking some time, few seconds. Okay. I think it's done. Yeah. So the last class that we will prepare, that will be our mangrove forest cover. Okay, because it has this striking orange color, we are going to collect samples from this particular part. Class ID, macro class ID will be 5 and class ID will be 1. Okay, so let's prepare our last class, which is mangrove forest cover. Okay, and then we will again click on this RY polygon, and of course you see, according to the coastal setting, you will find mangrove forest along the in a portion of the land which is a transition between your land and the sea. Okay. So start collecting the samples from here. Okay, so first pick up these orange striking colored pixels, all with NDVI value greater than 0.4. So we'll try to cover the pixels that are showing us NDVI value greater than 0.4. However, others are also included in it. Okay, so don't worry about it. Okay, one here and one here. So let's collect sample slightly from inward areas. You see, you can see some of the very dull color presented. This can be the this shows the unhealthy vegetation maybe. Okay, or the other reason can be the inundation the flood during the floods along the coastal regions, which has brought a lot of sand and silt along with its waters. So, but we can assume that this was the portion that where the mangroves were thriving. Okay. So you can repeat this process for images for different time interval, and you can analyze the changes in the cover. Okay. Let's collect few more samples. So based on these signatures, our image will be prepared. Our final supervised classified image will be prepared. So I hope you are getting the meaning of supervised classification. Okay, and if time permits, I will also try to include the unsupervised classification. Okay, like this. And I think here the signature is quite good. So I'll collect some from here. And I'm just zooming in and zooming out at different parts of this image using the mouse scroll bar. Okay, one more from here. And I think one we can collect from here. And even here you see the water body has some green vegetation due to which we can see some spectral signatures of healthy vegetation or some algae maybe. Okay, so I think these many samples are enough and we have collected them specially. Okay, we have distributed our samples specially. So let's take one more from here as well. Okay, one from here. Okay, now I'll finish this by saving the signature. So if you have any questions, please start writing in the chat box. Okay, I think we are done with image classification here at this point. And before we preview what we have done, so let's change the colors of these classes that we have prepared. Okay, so water bodies, double click on this water on the color, on the side of the water bodies, and select the color that you want to fill your water bodies with. Click on OK. For built up zones, you don't need to change the colors for your class IDs, because we are going to just use a macro class ID for our classification. Okay, click on OK. For built up zones, I'm going to use the red color. For agricultural land, I'm going to use this bright green color here. For bare soil or sand, I'll use this yellow color. Okay, and for mangrove forest cover, I'm going to use this dark green. Click on OK. Okay, so we have changed our color for our macro classes. Let's collapse them so that we can see all these things clearly on our image. Okay, now comes the test. How correctly we have classified our image. Before we prepare our final result, we can preview it. Okay, so by using this preview button, another very nice option before you prepare your final result. Okay, you can correct it anywhere if you have went wrong anywhere. So you click on this preview activation classification preview pointer here. Okay, and click anywhere in the image and it will give you a preview. Okay, so let me check here first. Okay, it will take some time. Yes, you see we have previewed this portion and you see this is a water body. Okay, and this portion is our urbanized according to this particular part, and you see this is correctly classified our urbanized part. Okay, and this is our mangrove cover, in which it has very nicely delineated this water body as well. Okay, and of course in this portion it is slightly it is showing the uh, it is confusing the signatures with the bare land. Okay, with the urbanized one. Okay, so but we can ignore it anyway, it is not our focus. Our focus is on the mangrove forest cover, which it is delineating quite nicely. Okay, so if we want to check it here at this particular portion, let's see how well it has classified our mangrove body. You see it has classified our mangrove portion very nicely as well, right? So we can ignore this part, or we can also refine this. Okay, if you want to put one more class, let's say others, if you want to put this particular spectral signature in some other class and calling it, let's say, miscellaneous or others, we can do that as well by creating one more class here. Okay, so that it differentiates the this built up areas from these exposed lands. Some maybe some other sort of plantation, some other sort of shrubs are here which is giving us this particular signature. Okay, so I think it's time we prepare our final image. First, let's again check. See, here it has delineated very nicely our bare land, okay, bare soil and sand, our agricultural farmlands, the water bodies, etc. Okay, so I think we are ready to finalize our result. So for that, what you have to do, you have to go to this window again here. Okay, here we have three type of algorithms. As I already said, we will use the minimum distance. Okay, minimum distance, and we can also prepare our classification report, which will be prepared in the form of uh, CSV. Okay, but let's not make it complicated at this point, and I'll simply run this. Okay, when you run it, it will take you to the folder in which you want to save your results. Okay, so I will say supervised mangrove forest. Okay, click on save. It will take few seconds again. Okay, yeah, so when you hear this sound, that means that it has prepared your final map, and you see your final classification, final the farmlands, how nicely it has delineated everything. Okay, maybe at some portions it has confused, for example at this portion, because we did not classify this part very nicely, we did not pick up the pixels very nicely. Now what if you want to refine your results? Okay, I'm not going to go into the detail of refinement, but I'm just going to demonstrate here so that if you want to learn, you can learn it through this video. So what if you want to reclassify or add some more signatures to the built up zone, or make it a another class? Okay, so you go to built up, highlight this, okay, and in micro ID change it to 2. You will be taken to built up zone. Okay, class ID change it to 1. Now again go to ROI and start selecting the samples. Start selecting the more samples for your uh, built up zones. Okay, and if you want to create one more class, then you can go with 6 and create others. Okay, and class ID 1, and now again just delineate this particular part and or start collecting sample for this particular region which has been confused with the urbanized areas, built up areas. Okay, you may separate this from the urbanized area by making another macro class. Okay, and then performing the same in the same way. Okay, performing all these things in the same way. Okay, so I hope this using the semi-automatic classification plugin is is clear with all of you, and you will again go through these videos and again practice on your own. Okay, so this is one of the ways in which you can use the automatic or semi-automatic algorithms in QGIS to map your land use and land cover in the region, and map, let's say, some environmental changes happening in the area. Okay, now again I want to put emphasis on the point that you can perform this analysis, you can perform these pixel classification or image classification for different time interval and analyze the changes. Okay, so again you see this is our raster image that we have created. Okay, now if you want to calculate the percentage of areas, right, and percentage of forest cover, percentage of different classes, then you can convert this raster to vectors. Okay, so let's convert this raster to vector. Supervised mangrove and DN, and this will be our classes. Okay, and make it vectorized, save it to file, and let's say I'll save it here and I'll call it supervised mangrove forest. Okay, click on save and click on run. So using this, we can classify our image into from raster to vector. Okay, if you will go to its attribute table, you will find these classes. Okay. Now, if you want to see the different classes in the vector format, then you may open the layer styling panel from here and change single symbol to categorized. Okay, value will be based on the classes and classify it. Okay, and delete everything that is not required. Okay, and you see you have got the classes in the vector format. Okay, now if you want, you can calculate the area for it. uh, I don't want to again go into the details of it, but first you can aggregate the particular vector file, vector format, aggregate based on the classes, different classes, and then calculate the areas. Okay, so I hope this was helpful using the semi automatic classification plugin, how you can integrate your remote sensing data to your GIS based analysis. Okay, next, is there any questions you have? So if you have any questions at this time, please you may write in the chat box. Okay. So from the very beginning of this webinar to till this point, we I hope you all have learned the importance of integration of GIS with remote sensing, and now I hope you all are aware that GIS is the skill that is need of an hour and can be very important skill in your career. So nowadays, as you all know, it is used in every sector. Okay, and every sector you can think of. So if we talk about especially about India, developing countries like India, so GIS has been a core foundation of major missions like e-governance and digital transformation programs such as Digital India, Swachh Bharat Mission, Smart Cities, etc., etc. And many states even have the state level GIS programs, okay, for sustainable development goals, education, forest cover mapping, soil health, and water resources. And nowadays, you might be finding out so many job opportunities that are open in the field of GIS, okay, using the open source and also the paid versions like ArcGIS. So QGIS being an open source makes the learning GIS first of all affordable, okay, for everyone, and it is not only used by small startups nowadays, but even bigger businesses is involving in these open source platforms. So if you are eager to learn QGIS in detail, and so visit our website questgis.co.in, okay, and explore our courses here. So we have our free courses, we have the webinars, we have some of the courses that we organized previously, and we also have the column for upcoming courses. If you when you directly come to our website, you will find all those links directly present on the top. So you may learn all the basics using the free courses. Okay, so it's a self-learning course which is completely free, and it has pre-recorded HD videos. It has a link for downloading QGIS. You can download QGIS directly from this link, and basics you can learn start from basics of GIS, and everything is in a very organized and systematic manner present in our website. So you may just click on this particular link if you want to learn about the QGIS interface and directly go to the in this lecture video. Okay, to the YouTube channel. First, also I'll request all of you to subscribe it. Okay, and check all the videos in our channel, whatever we have given in the free courses page. Okay, so explore our free courses, explore our webinars to get yourself acquainted with the QGIS. Okay, and also I'm at this point I'm pleased to announce that our upcoming course on QGIS fundamentals and application, in which we will provide in-depth training that will transform you from a beginner to a QGIS expert with live classes, practice sessions, and lifetime access to materials. And you mostly we organize live classes from Tuesday to Friday, and at 9 p.m. and at the time I think perfect for everyone. And remaining 3 days are open for our participants to practice and discuss queries, so that you become a you reach a particular level in QGIS by the end of this course, and we try to make you a pro in the QGIS and and by the end of the course you become confident enough that you can work on QGIS and start your open source journey. And also our relation with our participants does not end after a month, but it is forever. So you also get the lifetime access to the recorded videos, study material, and WhatsApp group where you can send your query, not only from the content related to our courses, but also from your own project. You can discuss your own projects anytime. Okay, even after the end of the training, our participants which participated in our courses 2 years back are still in touch, and they keep asking their questions, and based on their questions and if the time permits, we also prepare the YouTube tutorials, detailed tutorials on that. And all these you will get benefits only and only for rupees 2,999. So go to our website, download the full brochure, and grab the opportunity to learn the QGIS for a month. So the course starts from 1st April 2025 and it ends on 30th April 2025. So these the 3 days in which there is no live classes, that will be perfect for you to practice and learn at the same time you are learning the course. Okay, and the last day to register for this course is 31st March 2025. And if you are a student currently doing your masters or graduation, we have a special discount for you in the course fees. You may contact us directly on the given phone number. So we have given our phone number and contact details on every page of the website. You may directly contact us. So however, the course without discount is not very much, it's just 2,999, and by the end you will be confident enough to explore the QGIS on your own. Okay, and so just I'll just encourage all of you to grab the opportunity now. Okay, so let's get back to our course. Okay, so the last portion that we have to discuss is calculating the vegetation indices. Okay, in the same way we mapped our forest cover using our semi-automatic classification plugin, we can use these vegetation indices to understand the green vegetation, distribution of green vegetation. Okay, but these indices are also available, these mathematical equations are also available to find out the built up areas, to find out the water bodies, etc, etc. Okay, so what exactly these vegetation indices do? They indicate the amount of vegetation, percentage cover, okay, biomass, etc. They distinguish between soil and vegetation. They help us and they reduce actually the atmospheric and topographic effects if possible. Okay. So first, vegetation index, very important, which is our NDVI. NDVI is a numerical way to tell how much greenery is flourishing on our planet. NDVI helps estimate mangrove biomass and carbon storage. So ingredients, what are the ingredients that make NDVI? That is red light and near infrared. Okay, so the formula, that is NDVI is near infrared minus red band, near infrared plus red band. Okay, but and in case of Landsat 8 and 9 images, these bands are band 5 minus band 4, band 5 plus band 4. So, but how exactly it is done in QGIS? Okay, so I'm going to close all these images uh, now. Okay, because we just require these images. So I'll zoom it, zoom all these layers. So because we have to perform calculation, okay, at this point we have to understand that we have to perform calculation, and that is raster calculation. Okay, so in QGIS we have a raster calculator. So this raster calculation, the method that you're going to learn now for raster calculation, not only applies to your images, but it also applies to your digital elevation models. In the same way, you can write the expressions for digital elevation models. Okay, in the same way, you can write digital terrain models or anything raster, any data you have in raster, you can apply the raster calculator in the same way. Okay, so don't take it in a specific way, just take it in, learn this in a very generalized way. Okay, so for that you have to go to processing toolbox, and in search tab here, search for raster calculator. Okay, so here this raster calculator we are going to use. We have different raster calculators. You may try others as well. Raster calculator, double click. Input layers first we have to select. Using these three dots, we have to select our images. So we have to take band 4 and band 5. Okay, so band 5 and band 4. Click on OK. Now we have to write our expression. Okay, so our expression was brackets open band 5 minus band 4 brackets close divided by brackets open band 5 plus band 4 brackets close. Okay, so this is the formula for NDVI calculation. Click on OK. Okay, and let's keep everything as it is and save this to file as NDVI. Okay, so this is by default it will be saved as SDAT, but if you want you can keep it as TIFF. Okay, so let's keep it as SDAT here, save and click on run. Okay, so our NDVI raster is calculated. Okay, now again it is there in the gray band. Okay, so I'll go to layer styling of the raster. So for supervised mangrove forest, we did layer styling for vectors. Now we will do layer styling for our raster. So highlight the layer for which you want to perform layer styling. So after that, click on this first icon, open the layer styling panel. Okay, from here, single band gray to single band pseudo color, and there are different pseudo color ramps that you can use here to show the distribution of this NDVI values. Okay, for example spectral, for example greens, because we are dealing with the vegetation, so I'm going to use the green. Okay, but there are different settings that you can perform with your rasters. For example, minimum value settings, minimum maximum value settings. I'm going to use a cumulative count of these values so that all the unnecessary pixels are reclassified, or I just get the pixels that are important for me. Okay. Now statistic accuracy. For accuracy, I'll go for actual and slower. Okay, interpolation of these pixels, interpolation of these color ramps, I want to keep it as discrete. Okay, and from here continuous to I'll go with equal interval. Okay, and you see, and if you remember from our mangrove forest cover mapping, this entire area, okay, this entire area represents our mangrove forest cover, but here it has been classified in different class. Okay, so let's make our classes maybe 4 or 3 so that we get this entire coverage. Okay, of course it is taking this portion as well, because you see this also had the vegetation, very flourishing vegetation, or it shows the healthy vegetation in the agricultural farmlands. Okay, but if we want to cover this, we have to include this as well. Okay, but again, when you convert it to vector, you can just clip out this particular part. Okay, or you can combine different classification schemes, okay, to reclassify everything, you see. But quantile, with quantile it is not correct, because this is putting this particular part and this particular part in the same category, which we do not want. We will just go with the equal interval, because it is taking water bodies with in a different class. Okay, so this is what we want, and we can also redistribute these values. I'll go with the four classes. Okay, in this way you can make your own combination according to the final result that you require, and again convert this raster into vector in the same way we converted our supervised mangrove forest raster to supervised mangrove forest vectors. Okay, so next we are going to calculate. So you see, okay. So NDVI values, they ranges from -1 to 1. Higher the NDVI, the greener the scene, the lush forest and thriving crops. Okay, this is what exactly we saw in our results as well. These and negative values shows the desert, water bodies, and built up areas and barren lands as well. Okay, so let's go to another vegetation index that we will calculate. So next is our SAVI, is the soil adjusted vegetation index, and correct NDVI for the influence of soil brightness in areas where vegetative cover is low or where soil reflectance dominates the signal. This index is best suited in areas with relatively sparse vegetation where soil is visible through canopy. Okay, so let's calculate this SAVI. Here L is your soil brightness correction factor, and this parameter is usually set to 0.5 here. Okay, so let's apply this formula. This is band 5 minus band 4 into 1.5 divided by band 5 plus band 4 plus 0.5. Okay, in our Landsat 8 or 9 image. Again, we will go to processing toolbox. We will use the raster calculator. We will select our input layers, band 5 and band 4. Okay, so band 4 and band 5, click on OK. Write your expression here. Brackets open, band 5 minus band 4, brackets close, multiplied by 1.5. Okay, again put the brackets here. Okay, and then divided by, brackets open, band 5 plus band 4 plus 0.5 and brackets close. Let's verify our formula again. Yes, I think this looks correct. Okay, this is plus, and yeah, okay, looks perfect, and then click on OK. Okay, again you can save it to the file and call it as SAVI. Click on save, click on run, close it, and this is our SAVI. Okay, SAVI distribution. Again, we will style this layer to see our lush green forest. I'll perform the same settings for it as well. Okay, I'll use the cumulative count cut, and I'll change from single band gray to single band pseudo color. We will keep it as green. Interpolation will be our discrete. Minimum maximum setting, cumulative count. Okay, and here I'll go with equal interval like the one we used for NDVI, and I'll use it classes as 4. Okay, so now you can see that there is very small portion that shows changes in SAVI. Okay, because SAVI has corrected us for the barren for the soil. Okay, what it has corrected us for the soil brightness, for the influence of soil brightness, which we see in the NDVI. Okay, so this is another way you can map your particular vegetation or using the vegetation index of present in the soil, present in the satellite image. Okay, and in the end, I want to provide you provide the task for all our participants that you have to calculate this GNDVI. Okay, so basically GNDVI is a vegetation index that specifically emphasizes greenness. Again, it builds upon the principle of NDVI but focuses on the green portion of the spectrum. Okay, so if you can send me your final result for GNDVI and other indices through email, that will be really good. That will be really encouraging for me to come up with the new webinars, maybe in the remote sensing and GIS, because that makes me understand that you have understood the things properly and now you are ready to implement this. So this is a very small task for all of you. Practice this and try to calculate this with the provided data, and the formula is very simple, in which in this you have to select the band 5 and band 3, band 5 and band 3, and apply this formula. Okay, so if you can send me these NDVI, SAVI, and GNDVI calculation through email address I'll provide you. Okay, so that will be really good. I can assess what you have learned so far, and that will be again encouraging for me. Okay, so this is the this is the end of this webinar. Okay, so what we have learned so far, that I'm just going to brief it very quickly. First, we understood the basics of remote sensing and how GIS and remote sensing can be integrated together to visualize the data and analyze the data. Okay, just a moment. Yes, first visualize and analyze the data. Okay, and then we loaded our data, we learned how to install the plugin, we briefly saw how QGIS interface looks like and how we can install a plugin in QGIS. Okay, and then we loaded our images, loaded different bands of data, which is again not a traditional way of loading the raster data. This method applies only for your satellite images, which has different bands in which you want to process different bands. Then we saw the SCP dialog box, how what are the different settings, what are the different band processing and band set options present here, how we can load the particular images using SCP plugin. And then we went on to the theoretical portion to understand what image classification is, and that we saw the supervised image classification. We saw it practically in during our webinar. We learned how to process our image using supervised classification and bring out bring out the greenness, bring out the mangrove forest, or bring out the vegetation cover in our area using the semi-automatic classification plugin. Okay, and then we used the vegetation indexes like NDVI and SAVI to understand or to enhance the greenness in the area. Okay, and we reclassified the images using some layer styling options, which is a very simple thing to do, which is a very straightforward thing to do at first. Okay, then again, of course, we have different ways of reclassifying the images, raster images, which is again the out of the scope of this particular webinar. You can also assess the accuracy of your classification. Okay, which is again not in the part of this webinar. In this webinar, we just try to keep very simple things which you can understand easily and which you can work on and practice. Okay, so this is what by the end we learned how to map a particular land cover, because this was focused on mapping the mangrove forest cover. We just use the vegetation indices. If you are interested in learning the in enhancing the water bodies, then you have water indexes. If you are interested in understanding the built up areas, you have built up indexes. Okay, you have all these indexes present in the Google. You may go through all those indexes and you can apply the similar approach by using the raster calculator and semi-automatic classification plugin in QGIS. Okay, so I hope this was clear with all of you. And this is the end of this webinar. And if you have any questions, please ask your queries. I'm open to your questions now. And also, meanwhile, you write your questions. I would like to visit the website again and would like to tell you that your certificates will be available in this download certificates, download e-certificate but here. And here will be one button will be provided in few hours, using which you can download your certificate. And also, I'm thankful and I'm overwhelmed for your presence in this webinar. Okay, and from like the participants have registered from all over the globe, and that was really encouraging and overwhelming for me. And if you want to stay updated for our upcoming programs, upcoming events like webinars and some courses, free courses, paid courses, or YouTube videos, you may follow the Quest GIS on LinkedIn and stay in the WhatsApp group in which we have connected you, and subscribe the YouTube channel in which we bring the shorts videos, okay, in which you can learn things in just 1 minute, and how you can calculate the polygon area, clip out the polygons, etc., etc., which you can simply do in 1 minute. You don't need to go into the detail of 1 hour video. And the things which can be learned very quickly, that is given as shorts. And there is Instagram in which you can follow us. And also stay in touch through emails, send your queries through emails and WhatsApp, so that we stay connected and we learn from each other. Okay, so thank you again for joining this session. And let me go back to the chat box. Okay. uh, Estimating the carbon stock of mangrove is not a part of this webinar, Basir. We can discuss it later. Just send me the message on WhatsApp if you are connected in the WhatsApp group, or send me the email. So hopefully I will see you in the next session. Some of you will join our upcoming course in the next coming month, and we will learn more from the basics to the advanced level. And till then, keep upgrading yourself with QuestGIS YouTube channel, our post on the LinkedIn and all other social media networks, and send your queries. Thank you so much for joining. It was a pleasure delivering this webinar today. No, you don't need to have your registration number. I'll just provide you a single button using which you can click and just go through it, and you'll directly able to download your certificate. Please subscribe to our channel, the YouTube channel, and follow us. So we will now stop streaming this webinar. So thank you all for joining. Thank you so much. Please ask your question in the WhatsApp group as well, if you are practicing and uh, practicing through this webinar, and you know have are stuck somewhere, just ask your queries. Thank you so much. See you in the next session.